Hi everyone, welcome back to another video. In this video, we're going to take a look at the Grade 10 Physical Sciences September 2022 KZN paper. Now, before we begin, I'd like to remind you to please like this video, share and subscribe for more like this. And let's get started. Question number 1, multiple choice. Which one of the following is equal to 1 Hertz? So to answer this question, we got to think about the formula for frequency, because Hertz is frequency. Frequency is equal to 1 over period. So Hertz is equal to 1 over, and period is measured in seconds, so 1 over seconds. Now we can rewrite this. So Hertz is equal to, if I take that to the top, the exponent becomes negative, so s to the power minus 1. So the answer is D. Question 1.2. A very loud explosion can damage a person's hearing. This provides evidence that sound waves transfer energy. Because remember, it's the energy that's damaging the hearing. Question 1.3. What is the name given to the process by which a solid changes directly into a gas? That's a theory question. The answer is C, sublimation. Question 1.4. Which one of the following combinations shows two elements combining in the same fixed ratio? So what we're looking for is we are looking for a combination of an empirical formula and a molecular formula. Now remember, an empirical formula is a formula where the elements have been simplified. It's the simplest whole number ratio of elements in a compound. And if we go through them, you have H2O and H2O2, nope. SO2 and SO3, nope. And NO2 and N2O4, that is the correct answer. Because NO2 and N2O4, this is the simplest ratio. This is the actual one. In other words, if you multiply this by 2, you get N2O4. Question 1.5. What volume in dm cubed does 1 gram of hydrogen gas occupy at STP? So we can go ahead, calculate number of moles. So number of moles is equal to the given mass divided by the molar mass. It's 1 gram divided by, now remember, hydrogen gas is H2. So the molar mass is 2. That gives us 0.5 moles. Now, since this is at STP, we can use the formula N is equal to V over Vm. So N is equal to V over Vm. 0.5 is equal to V divided by 22.4. You can then cross multiply. You'll get 11.2 dm cubed is equal to V. So the answer to question 1.5 is B. Now let's take a look at 1.6. What will be the formula of compound XY if it consists of 1 mole of X and 1.5 moles of Y? So 1.6, you have X to Y, you have 1 to 1.5. Now you can't write x1 y 1.5 because that doesn't make sense. So what you got to do is multiply everything by 2, because that 0.5 can be eliminated by multiplying by 2. So you'll get x2 y3. So that answer is D. Question 1.7. What is the chemical name for Fe2SO4 So we can eliminate A and B because SO4 is a sulfate ion. So A and D is out. And we left with B and C. So is it going to be ion 2 or ion 3? So to calculate this or to figure it out, we got to do some calculations here. So Fe2SO4 3. So we know that a sulfate ion has a negative 2 charge. Okay, since there's 3 of it, this half is going to be negative 2 times 3, right? So for this entire compound to be neutral or have a sum of 0, what should the charge of Fe2 be? Well, Fe2 has got to be plus 6, because 6 minus 6 is 0. However, since we have 2 Fe's, each one has got to be plus 3. So you can solve it like that through inspection, or you can set up an equation. Now the equation you can set up is going to be the following. You can say that the SO4 has a charge of negative 2. So negative 2 times 3, and you are adding the charge of the Fe. Since there's 2 Fe's, and each Fe we're not sure about what the charge is going to be, let's call it X. So 2 from here multiplied by the charge of Fe, and then plus minus 2 times 3, because we have 3 SO4s and each one has a charge of negative 2. That's going to equal to 0 because it's neutral. So we can simplify. We can say 2x minus 6 is equal to 0. 2x is equal to 6. X is equal to 6 divided by 2, which is 3. So the answer here is iron 3 sulfate. The answer is C. Question 2.1 reads, the graph below shows two waves P and Q that are traveling in the same medium at the same time. Question 2.1.2 says, draw the shape of the resultant wave as the two waves P and Q cross at t equals 1.35 seconds. Indicate the value of the resultant amplitude on your diagram. So we first have to find out where 1.35 seconds is. So since there's symmetry in these waves, if this is 1.8, then this is going to be exactly halfway through. So that's going to be 0.9. So halfway between 0.9 and 1.8, that's going to be 1.35. So they want to know, or they want us to draw the resultant when this portion of the wave interacts with this portion of the wave. Now this is a crest and this is a trough. When you have a crest and a trough that are interacting at the same time, you are going to have destructive interference. So you have to subtract the amplitudes. So for B, or at this point B, the amplitude is negative 30, and here it's going to be positive 10. So when we draw our answer is going to be simply, so 2.1.2, because this side is larger, we are going to have a single pulse that's going to be here, and the amplitude of that pulse is going to be the difference between 30 and 10, which is 20. So that is going to be 20 millimeters. And that's it. I know the question is asking for the resulting wave, but because they've specified at a specific time, we only need to draw that. Question 2.1.3, what type of interference? As I said, it is destructive interference because you have a crest and a trough that's overlapping. Question 2.1.4, refer to wave P and give two reasons why a particle at point A and another particle at point C are in phase. So why are these 2 points in phase? So they are in phase because they are separated by a whole number of waves. Between A and C is actually one wave. So separated by one wave. And also point A and point C, they are at the maximum displacement. Those particles are at the same amplitude. So maximum displacement or amplitude. They have the same amplitude or displacement, however you want to think about it. Question 2.1.5 says, determine the frequency of wave Q. Now, wave Q is the dotted one, and frequency is basically asking us to calculate the number of waves per second. So if we count the waves, so for wave Q, that's going to be one wave and then two waves. We have two waves in 3.6 seconds, then one wave will be 3.6 divided by 2, which is equal to 1.6 seconds. So what we've calculated here is the period. So period is equal to 1.6 seconds. That's the time taken for one wave. So if you want the frequency, you can say 1 over the period. So 1 over 1.6, which is equal to 0.55 hertz. Or you could calculate the frequency like this if you wanted. You could say frequency is equal to number of waves divided by time. You have two waves and they've taken 3.6 seconds. That gives you 0.55 hertz as well. Question 2.1.6, calculate the value of the wavelength of Q. So wavelength is the distance between two consecutive points in phase. Now we don't actually have the distance between 2 points in phase. We have this distance here, 280 millimeters. So what is that measuring? That is measuring, that's one wave, that's half a wave, and that's a quarter. So it's measuring 1.75 or 1 3/4 waves. So 1 3/4 waves is 280 millimeters. Then we want the distance for one wave. So one wave is going to equal 280 divided by 1.75, which is equal to 160 millimeters. But wavelength must be in meters. So you got to divide this by 1,000. And that's going to give us 0.16 meters. Question 2.1.7, calculate the speed. So V is equal to F times lambda. Frequency was 0.55. Lambda is 0.16. And that gives us an answer of 0.088 meters per second. Question number 2. A learner uses a slinky to demonstrate the movement of a longitudinal wave. The slinky spring is fixed to a wall at one end while it is held on the other. He vibrates the spring using his hand. Question 2.2.1 reads, describe the hand movement that will be required in order to produce the wave pattern in the sketch above. Choose from perpendicular or parallel. So this resembles a longitudinal wave, right? And so a longitudinal wave has particles moving parallel. So the answer to this question is parallel. So I'm just going to write it like that, parallel. So question 2.2.2, why are we saying this? We are saying this because in a longitudinal wave, which this is, right, the particles move parallel to the motion of the wave. So because of that, the person's hand needs to move parallel to the wave as well. So question 2.2.3, calculate the period of the wave if it takes 5 seconds for a disturbance to move from X to Y. So from X to Y is 2 waves. So 2 waves takes 5 seconds. Now period measures the time it takes for one wave. So one wave is going to equal 5 divided by 2, which is 2.5 seconds. And the next question, what will happen to the disturbance mentioned in 2.2.3 immediately after striking the wall? Choose from move to the left, move to the right, or stops moving. Now, one way to think about this is sound is a longitudinal wave. And so if a sound travels this way, what's going to happen to the sound after it hits the wall? Well, it's going to reflect. And after it reflects, it's going to move to the left. So the answer here is moves left. Question 3. A motorist of a moving car sees an obstacle on the road ahead when he is at position 1 as indicated in the diagram below. Position 1 is x meters away from the obstacle. He sounds the car hooter while at position 1 and receives an echo 3 seconds later at position 2. The distance between position 1 and position 2 is 300 meters. If the speed of sound in air is 340 meters per second, show by calculation that the distance between point 2 and the obstacle is 360 meters. Okay, so let's go ahead and call the distance between this position and this position. That's going to be x minus 300 because the whole thing is x. This is 300 and so the balance must be x minus 300. And now we can use the formula. Speed is equal to distance divided by time, and we can solve for x. So we know the speed that the sound is traveling at. It's 340. Now, what is the distance that the sound is traveling? So the sound is going to travel that distance, so x, and then it's going to travel this distance here to position 2. So the distance is going to be x plus x minus 300. And the total time that it took is 3 seconds. Now you can cross multiply and then solve for x. X is going to equal 660 meters. So if this entire thing is 660 meters, then the distance from position 2 to the obstacle, so from position 2 to the obstacle, that's going to be 660 minus 300, which is equal to 360 meters. Now let's take a look at the next one, question 3.3. The diagram below shows the waveform produced by a pure sound note. Okay, they tell us the loudness of the sound note is now decreased to 1/3 of its original value and the pitch is halved. So 3.3.1, what is the value in centimeters of the new maximum displacement of particles in the medium? So they are asking what is the new amplitude. So loudness corresponds to amplitude. So if they have decreased the loudness to 1/3, that means they've decreased the amplitude by 1/3. So the current amplitude is 3. So 3 times 1/3, and that's going to be 1. So the new amplitude is going to be 1 centimeter. Question 3.3.2. What is the value in seconds of the new period? So pitch correlates to frequency, right? Now from the formula, F is equal to 1 over period. We can see that there is a relationship between frequency and period. Frequency is inversely proportional to period. So if the pitch is halved, if the frequency is halved, that means the period will increase. So if this is halved, this is going to double. So the current period is 0.4. That's the time taken for one wave. So you multiply that by 2, that's going to be 0.8 seconds. And the last question, question 3. We have explained it already. 3.4 now. What is the frequency range for medical equipment that uses ultrasound? Ultrasound is sound that humans cannot hear. Humans can hear up to 20,000 hertz. So ultrasound is going to be greater than 20,000 hertz. So between 20,000 hertz to about 100,000 hertz. Question 4 reads, study the following physical and chemical processes below. Substances X, Y, and Z are either reactants used or products formed during each process. So process 1, silver nitrate, is used in the manufacture of glass mirrors. We have X forming here. Process 2, carbon monoxide fumes from a motor car engine is released into the atmosphere and forms carbon dioxide. So you have Y as a reactant. And process 3, a block of ice melts completely. You have Z as a product. So 4.1.1 says, write down the symbol for substance X. So to figure this out, one way to solve it is to try and solve it by process of elimination here. So on the left hand side, you have Ag and you have NO3. Now you have nitrogen, you have oxygen, you have oxygen. So what's the one thing that hasn't moved over from the left hand side to the right hand side? Well, that's going to be Ag. So X must be Ag. All right, let's get the pen to work. Okay, so X is going to be Ag. Question 4.1.2. Write down the phase in which substance X exists. Well, again, one way to think of it is silver nitrate is used in the manufacture of glass mirrors. So glass mirror is a solid. So the silver that's forming should be a solid. So it is a solid. Again, if I can, there we go. Question 4.1.3. Write down the formula for substance Y. So carbon monoxide fumes from a motor car engine is released into the atmosphere and forms carbon dioxide. So what is the carbon monoxide going to react with in the air? Well, in the air we have oxygen, so it's going to react with oxygen, O2. 4.1.4. Just by the way, 4.1.3, there are other things that it could react with. However, if you look at the products that's there, you have two oxygens on the right hand side and you only have one on the left. So from all the gases that it could react with in the air, the most likely one is going to be oxygen. Question 4.1.4, the name of substance Z. So block of ice melting completely, it's water becoming water. So the answer here is going to be water. Question 4.1.5, write down the process that represents a synthesis reaction. A synthesis reaction is a reaction in which two things makes one thing. So process 2 shows carbon monoxide and oxygen forming a new compound, CO2. 4.1.6, write down the process that represents a decomposition reaction. Now, a decomposition reaction is where you have one thing becoming many things, and that's going to be process 1. Moving on to question 4.2, a learner performed 2 experiments at 2 different temperatures. One experiment was carried out at 30 degrees Celsius and the other 50. In both experiments, 178.50 grams of potassium bromide was reacted with 53.5 grams of iron 3 hydroxide to produce potassium hydroxide and iron 3 bromide. So question 4.2.1, write down a balanced equation for the reaction between potassium bromide and iron 3 hydroxide. So potassium bromide is KBr. KBr plus iron 3 hydroxide. Now, the 3 tells us the charge of the iron. So if you have Fe3 plus and you have hydroxide, which is OH minus, to have them balance, you need to switch the numbers here. So you're going to have Fe. Now, because OH is a polyatomic ion, we're going to use a bracket, and it's going to be OH, close the bracket, 3. And that's going to give us, now they tell us in the table the products. You have potassium hydroxide and you have iron 3 bromide. So potassium hydroxide is KOH. So KOH plus, and iron 3 bromide, once again, so Fe3 plus and Br minus. To have them balance, you switch the numbers. So you're going to have FeBr3. Now they want us to balance this. So in order to balance it, we need to put, there's 3 OHs on the left. So we'll put a 3 here. But that then gives us 3 potassiums. So we'll put 3 there. And so that does look like it's balanced now. Question 4.2.2, write down the value of I. So the value of I, we can calculate it. So the way we can do that is we can use the masses that they've given us. So they tell us that we've used, let's just make sure here, 178.50. So this is 178.50, and you have 53.50. So this is 53.50, and we have 84 grams of potassium hydroxide. So this is 84 grams. So to solve what this is, the mass of the iron 3 bromide, all we have to do is make sure that the masses are equal on both sides. So 178.5 plus 53.5 is going to equal 84 plus, let's call that x. Now we can solve for x. X is going to equal 148 grams, which is I. I is 148 grams. So question 4.2.3, how will the mass in 2, or here, formed in experiment 2 compared to the mass in 1? So the law of conservation of mass states that the total or the sum of the mass of the reactants is going to equal the sum of the mass of the products. That doesn't depend on the temperature. So if there was 148 grams in reaction 1 or experiment 1, then you're going to have 148 grams in experiment 2. So it's going to be the same. 4.2.3, it's going to be equal. Question 4.2.4, explain, okay, we've explained it. It's conservation of mass. Conservation of mass. Now, let's look at question number 5. Question 5, define the, okay, leave that out. Question 5.2, determine the number of oxygen atoms in 9.8 grams of H2SO4. So, first, let's calculate the number of moles. So, number of moles is equal to mass divided by molar mass. So, the mass is 9.8. The molar mass of H2SO4 we get from the periodic table. So we have 2 hydrogens, so that's 2, plus sulfur, which is 32, plus 4 into 16. That's going to give us 0.1 moles of H2SO4. Now, in 1 H2SO4, we have 4 oxygens. So if I have 0.1 moles of H2SO4, I'm going to have 4 times 0.1 oxygens. So the moles of oxygens is going to equal 0.4. Now I can calculate the number of atoms. So using the formula N is equal to capital N over Na. 0.4 is equal to capital N over 6.02 times 10 to the 23. You can now cross multiply. N is equal to 2.408 times 10 to the 23 atoms of oxygen. Question 5.3. The percentage hydrogen in a 34-gram sample of H2O2 is found to be 5.88 grams, or 5.88% rather. How will the percentage hydrogen be affected if the mass is increased? It's going to remain the same. Okay? And that's because 5.3.2 of the law of constant composition. The composition is not going to change. The percentage, rather, is not going to change. So if we had 5.88% of hydrogen, no matter what mass of it we have, it's still going to be 5.88. Question 5.4.1. A learner prepares a solution of NaOH of concentration 0.22 moles per dm cubed. She does this by dissolving 4.4 grams of NaOH in distilled water. Define concentration, leave that out. 5.4.2, determine the volume of the solution required to prepare the 0.22 moles per dm cubed solution. So we can use the formula, and this is a shortcut. Concentration is equal to mass divided by molar mass times volume. And this shortcut lets us solve it in one step as opposed to doing multiple steps. So the concentration is 0.22, and that's equal to the mass, which is 4.4. The molar mass of NaOH is going to be 23 plus 16 plus 1 times the volume. Now, we can solve volume by switching this value and that value. And the volume is going to equal 0.5 dm cubed. Now, let's take a look at question number 6. Question 6, a learner analyzed a 100-gram sample of hydrated aluminium chloride and found that 44.72 grams of the sample was composed of water. Question 6.2, determine the value of N in AlCl3 rather dot NH2O. So to solve this, I'm going to use a table. You don't have to use a table, you can solve it separately. So the table is going to be element, and this is, by the way, the same process that you would use to solve for empirical formula. So the next column, I'm going to put mass. The next column, I'm going to put moles. And remember, moles is equal to mass divided by molar mass. And then this one is going to be simplified. So here, I'm not going to put element, it's going to be element slash compound. So I'm going to separate them. I'm going to separate the AlCl3 and the H2O. So here I'm going to have AlCl3, and here I'm going to have H2O. So we know the mass of the water. It's 44.72 grams. So the mass of the aluminium chloride is going to be 100 minus 44.72, which is equal to 55.28 grams. Now to calculate the moles, we say mass divided by molar mass. So the mass 55.28 divided by the molar mass of AlCl3 we got to use the periodic table here. That works out to 133.5. And so this gives us 0.41 moles. The H2O is more easier. It's 42.72 divided by 18. And that gives us 2.48. Now what we want to do here is divide everything by the smallest number. And the smallest number here is 0.41. So 0.41 divided by 0.41 is 1. Then 2.48 divided by 0.41 is 6. So the answer here is AlCl3.6H2O. Question 6.3. So question 6.3 says, determine the percentage hydrogen in the sample. Okay, so there's actually a few ways you could do this. You could say that because it's a 100-gram sample, you can say that the percentage of H2O in the sample is equal to 44.72%. But the percentage of hydrogen in H2O is equal to, now there's two hydrogens, each hydrogen is 1, so it's 2 out of 18 times 100, which is equal to 11.11%. So what we want to work out is 11.11% of the 44.72%. And that gives us 4.97%. And because the mass is 100, that's going to be 4.97 grams. That's one way of solving it. Another way of solving it is to say, since we know the mass of the water is 44.72 grams, we can say, well, hydrogen is 2 out of 18. So 2 out of 18 times 44.72 also gives you 4.97 grams. And there's obviously another way. There's multiple ways you could do. You could do the molar mass method. It all gives you the same answer. Now, question number 7. Ammonium chloride reacts with calcium hydroxide according to the following balanced equation. So we have that reaction. If 5.6 grams of calcium hydroxide is used up completely in this reaction, calculate the number of moles of NH4Cl required for the reaction. So 7.1, we're going to calculate the number of moles of calcium hydroxide. So number of moles is equal to mass divided by molar mass. So 5.6 divided by, the molar mass of calcium hydroxide is 74. 5.6 divided by 74 is 0.08 moles. Now they want the moles of NH4Cl, so we have to do a mole ratio. So calcium hydroxide to NH4Cl is 1 to 2. So if I have 0.08 moles here, I'm going to have double that. So 2 into 0.08. And that's going to equal 0.16 moles of NH4Cl. Question 7.2, calculate the volume of NH3 gas formed at STP. So to calculate the volume of the gas, so to solve question 7.2, what we're going to do is we'd first need to figure out the number of moles of NH3. Now we know the number of moles of calcium hydroxide, so let's use a mole ratio. So calcium hydroxide to NH3 from the reaction is 1 to 2. So if I have 0.08 moles, the NH3 is going to be double that. So 2 times 0.08, which is 0.16 moles of NH3. Now, since they tell us that this is at STP, we can use the formula N is equal to V over Vm. 0.16 is equal to V over 22.4. That's a constant. So now we can cross multiply. V is equal to 3.58 dm cubed. And the last question, 7.3, calculate the percentage yield of NH3 gas if 2.9 dm cubed of NH3 is actually produced. So 7.3, to calculate the percentage yield, you take what you have. So we have 2.9 and you divide it by what you should have gotten. So we calculated here that we should have gotten 3.58. And then you multiply by 100. And that's equal to 81%. And that's the whole paper. If you stuck around, guys, thank you so much. Please don't forget to leave a like, share, and subscribe. And if there's anything more you'd like for me to do in terms of past papers or questions, please do let me know in the comment section below. I'll see you in the next one. Bye-bye.